Example 7, we talked about determining what methods would work in solving a particular quadratic equation. And these are the options that we had. We talked about solving by factoring, solving by square roots, solving by completing the square, and quadratic formula. And quadratic formula, remember, is the only one that works every time. Today, we are actually going to apply that, and we are going to spend some time solving. So this is a reminder from the last lesson. You should have this written down somewhere. Our discriminant, which is in the square root of our quadratic formula, which you need to have memorized, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Your discriminant is under the square root. If your discriminant produces a positive number, you get 2 real solutions. If it's 0, you get 1 real solution, and if it's negative, you get no real solutions. We used this yesterday to help us establish which methods would be appropriate on a particular equation. You should have this written down, but it's never a bad idea to rewrite things. If your equation has a quadratic term, but not a linear term, you're going to solve, your fastest method will be to solve using square roots. If your discriminant is a perfect square, you can solve by factoring. That means there are factors that will work. Quadratic formula works every time. You only want to complete the square when a is 1 and b is even. I would write this next part down and put a big box around it, make sure you remember it. The answer is no real solutions if you take the square root of a negative number. That occurs in any of these cases. If you are square rooting a negative number, your answer is no real solution, no matter what method you're using. So while we go through these examples, it's possible that you will not use the same method I'm using, and that's okay. You don't have to use the same method I'm using. We just have to get the same answer at the end. So, if I have 5x squared minus 8x minus 4 equals 0, I see that I have a linear term, so I'm going to rule out solving by square root right away. I look at my discriminant. That gives me 64 plus 80, gives me 144. Square root of 144 is a perfect square, so that means there's an option to solve by factoring. And since a is greater than 1 and I can't factor it out using a GCF, I'm going to use AC split. Multiply a times c, you get negative 20. Great thinking. Negative 10, positive 2. And I'm going to rewrite this without my linear term, instead using these two. So I'm going to have 5x squared minus 10x plus 2x minus 4 equals 0. I'm going to solve. Factor. So I'm going to factor out my GCF of these first two terms. Using 5x, so it'll leave me with x minus 2 plus 2. It will also leave me with x minus 2. Remember, that's the goal. Have two binomials that are the same. So I can write my leftovers in their own parentheses. Then I'm going to set each piece equal to 0. And solve. I got for my first one. You did not have to solve it in this manner. You could have. My next example, I have m squared minus 121 equals 0. I see that I do not have a linear term. I don't have that m term. So I'm going to solve using square roots, which jumps into just solving for m. Now to get rid of a square term, I square root. Those cancel. And then remember, here's the all-important step when you're square rooting something. You have to have two answers, a plus or minus, in order for it to work. We know that is plus or minus 11. On the test, you can figure your answer like that, or you could write it like this. The quizzes that you're taking on Canvas ask you to write it like this, because they don't have a plus or minus sign right there readily available for you. Next one. My next example, I have x squared plus 2x minus 63 equals 0. I see that I have a linear term, so I'm not going to use square roots to solve. If I plug into my discriminant, we get 2 squared minus 4, negative 63. That's going to give me 256. 256 does, in fact, create a perfect square. But so you can solve this by factoring. I'm not going to solve by factoring, but you can, but it's the same answer again. I'm going to solve by completing the square, because I see that A is 1, B is even. So remember, when you are completing the square, your first step is to get your constant to the right side. So I'm going to rewrite this as x squared plus 2x plus something, don't know what it is quite yet, equals positive 63. That's going to add it over, plus something. So I put a blank on the left, I got to put a blank on the right. Now to figure out what goes in the blank, I'm going to look at my b value. B is 2. I'm going to take that 2 and I'm going to divide it by 2. Gives me 1. Take that value, square it. In this case, it still gives me 1. Now I'm going to simplify. On my right-hand side, I have 64. On my left-hand side, I'm going to factor. Now we're going to x and x. And what multiplies to 1 adds to 2. That's positive 1, positive 1. Remember, the trick is that b divided by 2 value, that goes into both. So now I can rewrite this as x plus 1 squared equals 64. And I'm going to solve for x. You need to get x by itself, and you need to get rid of the square. So it's going to leave me with x plus 1. It's plus or minus, and we cannot forget that step. Square root of 64, which we know is plus or minus 8. To get x by itself, I'm going to subtract 1. If I make 2 equations out of this, I get 7 and negative 9. Now, there are a couple of ways you could have solved that one. You could have solved by factoring. You could have solved by moving the square like I did. You could have solved by quadratic formula. You could have used any of those methods. They would all be correct. As long as you did the word correct, you would get the same answer I got. Looking at example B, I have a linear term, so I can rule out solving by square roots. If I plug into my discriminant, I get 21, and that doesn't have a nice square root, so that means solving by factoring will not work. If I want to go completing the square, that won't be a good idea because A is greater than 1, B is odd, so we don't really know how to solve by completing the square. So it seems like quadratic formula is my best bet. So I'm going to take my values. So we established that we are using quadratic formula to solve this one. It's the only one that'll work. So I'm going to plug this into my quadratic formula, which you need to have memorized. negative b plus or minus the square root b squared minus 4ac all over 2a. I plug that in. I'm going to have negative 9 plus or minus negative 9 squared minus 4 times 5 times 3 all over 2 times 5. And simplify that. This is going to give me a positive 9. We actually already simplified this part when we did our discriminant earlier, but just for the sake of working through it, we're going to redo it. This is going to give me 9 plus or minus square root of 21 over 10. Now, if I can simplify that radical, I should. So factors of 21 are 7 and 3. Since those are both prime, I can't simplify this any further. So actually, this is my answer. Now you could leave it like this, or you could put it into 2 answers. Either would be acceptable. Now, on the next two, I am going to not do as much talking. I'm just going to decide kind of for myself. And then on the last two, I'm just going to put answers up, and you are in charge of figuring out yourself, making sure you and I agree on answers. So I think I'm going to solve by factoring here. I'm going to divide everything by 5. So it's going to be x squared minus 1x minus 20, 0 divided by 5 is still 0. I solve by factoring. Since a is 1, I can jump right in. Negative 5, positive 4. I'm going to set each binomial equal to 0. Here's what I'm getting. Example B, I'm going to use quadratic formula. These values. Remember, once again, you need to have this memorized. Negative b plus or minus square root b squared minus 4ac all over 2a. Take negative 1 plus or minus square root of 1 squared minus 4 times 8 times negative 8. 2 times 8. It's going to give me negative 1 plus or minus square root of 1 plus 256 over 16, which is this. Now, if we can simplify that radical, we should. But I don't think 257 has any factors. So that means we can leave our answer just like this, or we can write it as 2 separates. For your last two, I am just going to write answers. If you are not getting the same answer as me, please raise your hand so I can help you. Here's what I have.